All right, so at 0, it's 0. And then at pi over 2, think of 90 degrees up at the top on the unit circle. The ordered pair is 0, 1, and so the y-coordinate is 1. And then at pi, you're over at 180 degrees. The ordered pair at pi is negative 1, 0, and so the y-coordinate is 0 at pi. And then 3 pi over 2 is down at 270 at the bottom. The ordered pair is 0, negative 1. And so the sign of 3 pi over 2 would be negative 1. And then at 2 pi, you're back at the same place as 0, so 1, 0. So the y-coordinate is 0. All right, so now we can plot those points. So 0, 0. Pi over 2, 1 is going to be up here. Pi 0. 3 pi over 2, negative 1, and then 2 pi 0. All right, we have these 5 points, and then we can connect them. And so this is what the graph's going to look like. So the way sine graphs work is they oscillate back and forth. It's kind of like a wave. They just repeat the same pattern over and over again, forever. All right, so the shape that we want to memorize for sine graphs, okay, it's going to start at the origin, 0, 0, goes up and down, and ends on the x-axis. So that's the shape that we start with for all sine graphs. All right, the period is the horizontal length of one cycle of the graph. All right, it's the horizontal distance from the left side to the right side. So this is the length of one cycle. And so we can see that the length from here to here is 2 pi. All right, the amplitude is if you take the lowest point and the highest point, add that distance together, and then cut it in half. Right? So the distance from negative 1 to positive 1 is 2 units. And if we cut that in half, it's 1 unit. And so that's what the amplitude is. All right, so these graphs, they just keep repeating the same pattern over and over again. So I can extend this graph with another cycle going to the right by just adding these extra points down here. All right, so I have another cycle. All right, so again, I can see the distance from 2 pi to 4 pi. This distance is 2 pi units. Just like this distance from here to here is 2 pi. This is 2 pi also. I can extend this graph going to the left also. All right, so my points would be right here. And again, they just keep going forever, just creating another period, another period, another period. Right? So the domain of a sine graph, since it repeats forever going to left and right, is going to be negative infinity to positive infinity. All right, the range, if you remember, we look at what horizontal lines intersect our graph as we move from bottom to top. Right? So down here at negative infinity, it's never going to hit. Not until we hit negative 1. Right? And then it's going to continue to hit all the way to positive 1. Then it's not going to hit after because nothing goes higher than positive. So the range is going to be from negative 1 to positive. And we use brackets because it does intersect our graph. All right, so that's the basics behind a sine graph. So you can see how we get all those points. All right, so let's do a cosine graph. So y equals cosine x. So cosine are the x coordinates of the ordered pairs. All right, so we'll use the same values, okay, for our angles. So at 0 radians, the ordered pair is 1, 0. So that means the cosine of 0 is going to be 1. At pi over 2, you're up at 90 degrees. The ordered pair is 0, 1. So cosine of pi over 2 would be 0. At pi, the ordered pair is negative 1, 0. So the x-coordinate is negative 1. At 3 pi over 2, the ordered pair is 0, negative 1. So the x-coordinate is 0. And then at 2 pi, you're back at the same place as 0. And so the x-coordinate is 1. All right, so plotting these points, so 0, 1, pi over 2, 0, pi negative 1. Oh, no, way down there. All right, and then 3 pi over 2, 0, and then 2 pi positive. Right, so there's our 5 points. If we connect them, we're going to get a graph that looks something like this. So you can kind of think of a parabola. Right? So if we were graphing the basic shape, you start high on the y-axis, and it comes down, crosses through the x-axis, then comes back up, and ends high on the same place that we started on the y-axis. Right? So it starts high, ends high. All right. So then the period we can see is the horizontal length. So again, it's this horizontal distance before it starts to repeat. And so that's 2 pi. The amplitude, again, is going to be 1. It's half the distance between the lowest point and the highest point. So between negative 1 and positive 1, that's 2 units. So half of that is 1 unit. All right, the domain is going to be negative infinity to positive infinity again, just like the sine. And then the range is negative 1 to positive 1. All right, again, we could extend this graph. Right. So there's another cycle. We could extend it to the left also. Okay, there's another cycle. So that's showing 3 cycles of the graph, where each cycle has a length of 2 pi. All right, so our basic equations for sine and cosine graphs, y equals a times the sine or cosine of bx minus c plus b. All right, so the a value gives us our amplitude. All right, so to find the amplitude, we're going to take the absolute value of whatever that number is in front. It could be positive or it could be negative. But when we take the absolute value of it, the answer is always going to end up being positive. All right, so amplitude is always a positive number. It's always based off the number in front. All right, find the period, how long horizontal distance that one cycle takes. We're going to do 2 pi divided by the b value. The b value is the number that's being multiplied to x in parentheses. Right, so 2 pi divided by b gives us the horizontal length of one cycle. That's called period. All right, the other 2 letters, the c and the d, deal with translations. So that's shifting when we do transformations, which we'll do the transformations on Monday. All right, so the d value, if it's positive, that means the graph's going to shift up, and if it's negative, it would shift down. All right, so that's your vertical shift up and down. And that gives us what's called the midline. And so we're going to write the equation of that midline as y equals, and then whatever the d value is. If it's 0, there's no number there, then 0. All right, and then we have phase shift. So that's shifting left and right. They call it a phase shift in trig. instead of saying shifting left and right, we call it the phase shift. So to get that phase shift, figure out how far it's shifting left or right, we're going to do the C value divided by the B value. And you got to remember to do the opposite sign, because if it's a negative inside, a subtraction, we do the opposite. So it changes to a plus, which means it would shift to the right. If it's a plus inside, we do the opposite, which changes to a minus. And because it's negative, it would shift to the right. All right, so that's why you got to remember to do the opposite. All right, so again, we'll do the shifting up, down, left, and right on Monday. Today, we're just going to look at the basic shapes and getting the amplitude and period. All right, so let's go ahead and practice each of these. So given number 1, y equals -5 times the sine of 2x, we want to give the amplitude and period. All right, so to get the amplitude, we're going to take the absolute value of the a. So the a value is -5, and so the absolute value of -5 is +5. All right, the period, we're going to do 2 pi and divide it by the b value. So the b value in this case is 2. So again, -5 is a, 2 is our b value. So if we simplify this, it'll simplify to pi. So what this says is the horizontal distance of one cycle of the graph would be pi units long before it starts to repeat again. All right, number 2, amplitude, absolute value of 1/2 is still 1/2. The period, we're going to do 2 pi divided by b. Now this one's a little different because it says x over 2. Well, x over 2 can be rewritten as 1/2 times x. It's the same thing. So that means the b value is 1/2. So now we have to simplify this. It's a complex fraction. So what would 2 pi divided by 1/2 simplify to? Yeah, good. So 2 pi divided by 1/2, you can multiply it by the reciprocal, okay, which would be 2 over 1. So 2 pi times 2 over 1 is 4 pi. All right? So that means that every 4 pi, the cycle would repeat. All right, number 3, absolute value of -2 is +2. Period, we're going to do 2 pi divided by 8. And we simplify this down to pi over 4. All right, so go ahead and do 4, 5, and 6. List the amplitude and the period for each one. All right, so remember when you have a complex fraction, multiply the top number by the reciprocal of the denominator. All right, so go ahead and turn it over. Now we're going to go ahead and start graphing. All right, so let's get our amplitude and period in first. All right, so number 7, the amplitude is 3. And our period, 2 pi divided by 2 is pi. All right, so we got our amplitude and our period. All right, so the way that you start graphing is you're going to always count out 4 tick marks to the right. Okay, it's always 4. And that 4th one you're going to always label as your period. So whatever your period answer is, that's the 4th tick mark's value. So in this case, it's pi. All right, now we have to give the values of the other 3 tick marks. So the way that you do that is you take your period, whatever it was, and you're going to cut it in half, or multiply it by a half, or divide it by 2. You always take half of this number. That's going to give you the second value tick mark, because that's half of 4. All right, it gives you the halfway point right here. So we take half of pi, it's pi over 2. All right, now to get the first value tick mark, we're going to take half of this distance. That means we take half of this number. That just means multiply by half. So if you multiply pi over 2 times 1 over 2, that's multiplied by half, what would that be? Pi over 4, right. All right, pi over 4 is half of pi over 2. Now to get the third tick mark, you're going to take the first one, multiply it by 3. Because that's the third tick mark's value, whatever the first one is, times 3. So 3 times pi over 4 would be 3 pi over 4. All right, so we've labeled all the values on the x-axis for one cycle, one period in length. Now we want to label our y-axis. All right, so that's all based off your amplitude. So the amplitude number, that means the highest number that we're going to go is the positive 3. And the lowest we're going to go down to is negative 3. Okay, if you want to put the other numbers in, that's fine, but at least show me the highest you're going and the lowest, and that's all based off the amplitude. All right, now you want to get the idea of what the shape of this graph is going to look like before you start plotting all your points. All right, so this is a sine graph, and a sine graph always starts at the origin. It goes up, down, and then stops on the x-axis. So it starts on the x-axis, ends on the x-axis. That's our shape. So we can put in the 5 points that make up this graph. All right, so the first point is at 0, 0. Then we're going to start to go up. So we're going to go up to the highest point at 3, but we had to shift it over to the right 1 unit, which is pi over 4. All right, now we're going to start to come back down, and we're going to cross through that second tick mark value at pi over 2. Then it's going to come through and go to the lowest at negative 3. And then it's going to turn back around and end on the x-axis at pi. So we have those 5 points, now we can connect them. So this is why it's important to understand the shape of these graphs. So once you put your 5 points, you can just connect them. So that's one cycle of the sine graph. All right, so then we can get the domain and range. So the domain's always going to be negative infinity to positive infinity, and that's because these graphs oscillate back and forth forever in both directions. We're just showing one cycle now. And then the range is going to be from negative 3 to positive 3, and that's because the lowest that we're going is negative 3, okay, all the way up to positive 3 times. So start with negative 3 and positive 3. All right, so that's really all you need to understand for this, this graph. All right, so let's do number 8. So now we have a cosine graph. All right, amplitude is 1/2. Period, we're going to do 2 pi divided by 4, which is pi over 2. So we're going to go 4 tick marks to the right and put pi over 2. All right, so we're going to take that pi over 2, we're going to cut it in half. That'll get us the second tick mark value. So if we take pi over 2 and multiply it by a half, what is that? Pi over 4, okay. All right, now to get the first tick mark value, we're going to take pi over 4 and multiply that by a half. So what does that become? Pi over 8. Okay. All right, now to get the third tick mark value, we're going to take that first one, multiply by 3. Right, so 3 times pi over 8 is 3 pi over 8. All right, so the x-axis is labeled. All right, the y-axis, we're going to go up to a highest point of a half and to a lowest point of negative a half. So you can scale your y-axis any way you want. If you want to put 1/2 here, that's fine. And then negative a half down here. We'll make this 1, and this is a half. Negative 1, that's negative a half then. So it's up to you. Just make sure you're showing your values. All right, so this is a cosine graph. So our basic shape is going to start high on the y-axis, come down through it, and then end high. So it starts high, ends high. Think of a parabola. All right, so now we can just plot those 5 points. And then connect them. All right, so that's one cycle of the graph. Our domain is going to be negative infinity to positive infinity again. Our range is going to be negative a half to positive a half. All right, and then let's do 9. Y equals negative 2 times the sine of pi x. All right, so our amplitude is the absolute value of negative 2, which is positive 2. Our period, 2 pi divided by pi, which is 2. All right, so let's count out 4 tick marks. Our period is 2. We'll cut that in half. That's 1. We'll cut that in half. That's a half. Multiply a half times 3. That's 3 halves. All right, our amplitude is 2, so our highest point that we're going to go to is positive 2. Our lowest is negative 2. All right, so now the basic shape of this graph, this is a sine graph, but it has a negative in front, which means there's an x-axis reflection. So the sine graph's still going to start at 0, 0, but instead of going up, it's going to start to go down, then cross through, come up, and then end on the x-axis again. So still going to start and end on the x-axis, but there's a reflection. All right, so now when we plot this, we start at 0, 0. Now we're going to start to go down first and start to come back up, cross through the x-axis, go to the highest point, and then end on the x-axis. So now we can connect them. All right, so this is our sine graph, has a period of 2, amplitude 2, x-axis reflection. Our domain, negative infinity to positive infinity. Our range, negative 2 to positive 2. So go ahead and do number 10. Be able to do that one? Oh, yeah, yeah. No, but I'm going over this one right now. Did you already do this one?